Hello, today we're going to talk very briefly about Cushing's triad and traumatic brain injuries, what's happening and how we treat them. So a very brief overview is the brain undergoes a brief amount of trauma. We call this a coup and contra coup. If you think of the brain as living inside of a closed container, then you realize that it will have to escape the confines of the skull through a hole in order for the brain to go down into the spinal cord. We call this hole the foramen magnum. The areas closest to this hole in here are known as the diencephalon and the brainstem. They house very important features that control very basic functions of our being, such as heart rate, respiration rate, gag reflexes, as well as the dilation and constriction of our blood vessels. All of these are housed in this section of the brain. Unfortunately, when the brain undergoes trauma, bouncing back and forth, bleeding can occur. This will fill in the space, and the brain has nowhere to go except through the foramen magnum. As it herniates through the hole, we start to see various changes. If you think back to GCS, the Glasgow Coma Scale, you'll remember that we have decerebrate posturing and decorticate posturing, also known as abnormal flexion and abnormal extension. What do these have to do with the brain? Well, as the brain starts to herniate through the foramen magnum, we first start to see these decorticate features, meaning that the core, the brain core, is now herniating through the foramen magnum. When the swelling becomes more severe, we start to see decerebrate, cerebral, as in the cerebrum area of the brain. More of the brain is herniating out of the foramen magnum during this portion of the body's response to the traumatic brain injury. So, what do we see for Cushing's triad? We see three distinct features. One, we see irregular respirations. We also see a decrease in heart rate. And we also see a widening of the pulse pressures. And again, all of these features come because of damage to the core of the brain affected in this area. So, what is the goal of treating this? Well, we want to reduce swelling in here. The only way we really have to reduce swelling is by increasing intrathoracic pressure via hyperventilation with positive pressure ventilation, PVM, and positive pressure ventilation. This will increase intrathoracic pressure, which causes the body to have a decrease in cardiac output, which then causes the body to increase the effects of the sympathetic nervous system, causing you to draw in more blood and fluid from interstitial spaces, including the brain. This is all in an effort to slightly reduce intracerebral pressure in the brain, because really it's not the insult to the brain that causes the long-term damage. It's the long-term swelling of the brain over a long period of time. Thank you guys very much.